The title of my talk, as you can see, is squarely focused on cellular networks. So I understand that cellular networks sometimes in the academic community are perceived to be, yeah, this is something the industry people do and write lots of big, giant standards about. It's not as interesting as a lot of the element stuff we do. So there's a little bit of a rant in my presentation about that, how we need to bring more academic people doing the kind of things we are doing, and hopefully I can convince you in that direction. So just a minor statement, I'm part of actually a center called Networking and Network Management Research Center, and I'm part of a department that essentially focuses on wireless network elements oriented research. So the overview of my talk is going to be as follows. I'm going to sort of quickly review the emerging trends that are out there, then talk about challenges that are currently facing cellular networks, specifically the need for multi-port increase in per digital throughput, and how you potentially reduce the cost structure in the network. The overarching question that we are going to try to answer is, can the cognitive radio and cognitive networking help in this direction? And we would like to say yes. To answer that question, I sort of provide some illustrative technologies that we are currently exploring that we believe are good examples of cognitive radio and cognitive networking, so to say. And this was the last sort of more, how should I say, a question I wanted to pose to the audience. Why is it that the academic groups are not quote-unquote smelling the coffee? I mean, here's an exciting area out there. Why is it that we don't see significant academic activity on this kind of topics? The kind of problems that we are talking about, our argument is that those are the problems that will immediately show in the wireless networking world in the next 5 to 10 years, rather than some of the more futuristic scenarios that are often talked about in academic conferences. So this is intended to generate more discussion from your end. So, hi Ray, how are you? So maybe just for your benefit, I'm going to again put the last bullet down there so you can start reading. So I think the natural question one may ask is, why bother about cellular networks? And I think if you think a little, you will agree that cellular networks of today are essentially a good success story, and they have become a critical infrastructure. You already have more than 2.5 billion customers. By 2010, you will have about 3.5 billion cellular customers who would be using about 14.7 trillion voice minutes, generating a revenue of about 800 billion in annual total revenue, right? And the rapid growth in subscriber base is continuing at a very strong pace, especially in places like India and China and some other developing countries. And if you look at the distribution of these users, the GSM users tend to be inordinately large number, about 77% of the users are GSM, and 67% of the revenues are generated by these users. CDMA tends to be a distant second, only 15% of the users, but they come from typically higher paying part of the world, Japan, US, Korea, so 20% of the world market revenue comes from these users, right? And large number of the service, as I illustrated, is dominated by voice, and very small percent currently is in the data services. So only 10%, roughly 295 million users of the 2.8 billion are the data users, essentially the people who have Apple iPhones and people who use privacy video network and similar, right? But we believe that we are at a kind of inflection point in the history of the cellular networking, and kind of a new transformation is already underway in terms of the user habits, the kind of applications, the demographics, and the devices that we are going to see. So the natural question from the service provider point of view or from the vendor point of view we have to be able to answer is, are the wireless networks going to be able to keep up with this transformation that is happening? And to illustrate,
so you have figures on revenue. Do you also have some idea of how much profits these cellular companies have made?
Yeah, so I think profit, I have some numbers on that, and the point that we are trying to make is that the per user gain that you have starts decreasing. The famous number that people quote is the ARPU, average revenue per user, right? That unfortunately is quite down. So that's where some other challenges are. So if we were to understand this transformation a little bit better, let's do a quick run through. The demographics is already changing, especially in the US, where you're going from the so-called baby boom generation to the millennials. And their habits on the internet, the way they use information and connectivity is also gradually changing. So from today's older generation, the baby boomers, who essentially were passive consumers of content, you are gradually going towards more and more interactive, more and more life-sharing kind of applications. So the so-called Gen Y is already tightly tied into Facebook, Twitter, Flickr. I'm personally not very big on Twitter and Flickr, but it's amazing to see how much my wife is into it, how her friends are into it, and how the tree of her friends, if you look down that, how big it is in terms of the interaction that they have on a daily basis. I'm actually very poor at it, but that's more of a personal choice and less to do with the sophistication that those applications provide, right? But the bottom line is that the user trends are shifting from more personal to more community kind of applications, which requires instant connectivity, which requires rapid, always-on connectivity, right? And this generation evolution is going to strengthen as the demographic gradually changes, right? Also, long-term trend is that the devices are going to proliferate. As more and more machine-to-machine applications, more and more consumer applications are going to come online. So traditionally, we have had tons of different devices. You have had phones, you have had cameras, you have had in-car devices, right? Eventually, you can imagine that your phone is a single device, or it at least has interfaces to different spaces that you deal on a day-to-day basis. So the more devices come online, and also the more sophisticated your phones get, the more increase in the volume of the traffic you're going to experience, and the diversity of the traffic is going to change, because the same device is going to do all different kind of applications, right? But unfortunate fact of life is that subscribers typically have a certain sense of how much they want to be willing to pay for a given connectivity service, communication service. They don't want to pay a whole lot. So if you look at the cellular services revenue in 2005, it was about 563 billion, and in 2010, it's going to go to about 800 billion. But if you look at the other metric, the average revenue per user per month, that is only $28 in 2005, and believe it or not, in 2010 it's actually dropping to roughly $24, right? So the revenues went up 42%, but the ARPU went down 16%. So every user that you add into your network user population, your incremental revenue is actually going down. So the addition into your, so the rate of revenue growth is dramatically slowing down, right?
It's not clear what the reason for that is.
Also, I think this statistics, I'm pulling it out more for dramatic impact. The caveat here is that the users that have come on board are typically from the lower income or developing countries, right, where a lot of the people go on prepaid plans and their usage pattern is still at the bottom of the barrel kind of user pattern, where more voice-oriented traffic, right? But still, even in developing world, you would experience that the ARPU, growing the ARPU has been the biggest challenge for service providers, right? The data users tend to generate a bit more in comparison. So if you look at the WCDMA, the kind of network AT&T operates, right? The average revenue is about $65. But if you go to the CDMA 1, CDMA 2000, which is the Verizon network, it's about $36, $37, right? And in comparison, the voice users give you about $25. So if you are a service provider, your job, if it's to grow large revenue, naturally you start focusing more on data services. And second, you try to minimize your margin, so to say, right? By reducing your total cost, the cost of deploying the network, the cost of operating the network, the so-called capital expenditure and operating expenditure, right? So So the three main things sort of you are interested in doing if you're a service provider. You want to increase the performance and the capacity. So from the current sort of hundreds of kilobits per second, you want to be able to go to multi-megabits per user kind of throughput. So that's an order of magnitude improvement in terms of throughput, right? So the natural question you're going to ask is, how do you go about doing that? And if you think a little bit, there are only a few ways you can do it. And to give you sort of clarity on what I'm saying, let's take an example of squeezing an orange. So think about spectrum as orange, right? If I have a single orange, maybe 50 years ago I had something called a handheld juicer. I used that to get the juice out, right? But quickly I realized that it's not doing a good job. So I went and invented a mechanical juicer, and then I went and invented another juicer that's an electrical juicer, right? Soon I came to the conclusion, I'm not doing so good. I just need to get a bigger orange. Or maybe I need to go and get more oranges, either small or large, right? Spectrum is much like that. So if you look at the spectrum that is given to you as a licensed spectrum, right? You as a provider are holding an orange. Your job is to squeeze the maximum amount of juice out. So what you do is you go and first try to use very spectrally efficient modulation techniques. You employ things like MIMO and improve the bits per second per hertz that you can get out of this licensed hertz that has been given to you, right? On the other hand, you may also go and try to improve what is known as area spectral efficiency, the ASE, the bits per seconds per hertz per meter square, right? So you start making your cells smaller in size. You start using wider channels, as in WiMAX and LTE that you are already seeing, right? At the end of it, as you can imagine, these are all the squeezing devices that you're using, right? There comes a point where you can't squeeze anymore. If you want to have order of magnitude improvement, you have to go and get more oranges. You need to get more spectrum, right? So how do you go about doing that? All of these things is the challenge that you face when you are trying to improve performance, right? The other problem that you're facing, as I said, is the capital expenditure and the operating expenditure reduction. And the third is, as you introduce new technologies, likely there will be new entrants in the market. Still, service provider business tends to be more of an oligopoly. I mean, there aren't like flood of new entrants, but you still have once in a while a company like Clearwire trying to deploy a nationwide network, right? But are there new market entrants on the horizon? And if there are, how do you help them, A, and B, how do they change the market forces, right? So as a service provider and as a vendor, you have to be cognizant of these challenges. And anything you do, whether it's cognitive, whether it's not, your job is to be able to meet these challenges. So I'm sort of trying to give you a perspective from where I'm coming from, right? So already, as I mentioned, the cellular network architecture is gradually evolving. The providers were already looking into what are known as femtocells and small cells. This is a way of reducing the cell size and improving the area spectral efficiency. So you have a large macro cell within which there are small cells that are embedded. It's typically an indoor cell. It's called a femtocell. And inter-femto interference is normally very much a non-issue because of the good shielding properties that a house or an enterprise building or indoor space provides you, right? So you have a femto base station in the house, and then you have, of course, the client devices in the house that are the customers of that home base station. And that home base station is connected to the internet by typically a high-speed backhaul like DSL cable modem or even fiber connection, right? The flip side of the femtocells are the so-called small cells, which are typically deployed outdoor, but they have a traditionally smaller coverage area, and they have a different interference relationship. The macro cells that are they are embedded in, right? So the claim is that by deploying femtocells, you are actually offloading the load from the big macro cell. So when you are inside this small cell, you are no longer using the resources on the air to the macro cell. So you are offloading the capacity to the femtocell. So that essentially reduces the load on the macro cell, potentially improves the performance and the capacity in the macro cell, right? And also you're improving the coverage and the throughput indoor because, of course, the coverage is obvious and indoor because you have a shorter link and you have potentially symmetric link, so your up and down link performance could be potentially better, right? So where is the problem? So if you look at how the network is already evolving, in the past you have had a typically one single macro cellular layer, right? But now you have additional two new layers that are emerging in the service provider network, the so-called small cell and then the femto cell. And as you go up the layer, the number of cells is going to start increasing, right? The scale of the network is going to dramatically change. From hundreds of thousands of base stations, you potentially have hundreds of thousands and millions of base stations that you have to deal with as a provider, right? So the older models that you have for managing and running the networks are not going to be necessarily good models, right? Also, the interference interactions that you had to deal with, typically you had only interactions within the macrocellular network that you had to deal with. Now you have interactions across the layers and also interactions within the layer that you have to deal with. And these interactions depend essentially on the kind of spectrum usage that you are doing. So if I look at the existing scenario, which is operating only in the license band, where every provider is given its own license band, right? And you are increasingly using wider air interfaces.
Sure. So how is this small cell different from a micro cell or a pico cell? I mean, are you saying the same thing, or is it something else?
It is similar. I mean, it's if you want to think of it as a micro and a picocell are examples of small cells, but the way they are deployed is going to be peculiar. In the sense, as an example, you can have in the New York City when you're walking down a block, you have those advertisement panels, right? Those advertisement panels typically become your antenna element, and then you have a backhaul coming into that place, which not only supplies instant advertisement feed to that place, but also becomes a high volume backhaul for the base station. Right? So that kind of deployment is typically called small cell deployment. But you're right. I think historically people have talked about picocells and microcells, so they are kind of that. But the scale of deployment is expected to be much more extensive going forward, unlike in the past, where it was only for filling coverage goals and things of that nature. So if you are going to increasingly wider channels like 20 megahertz LTE or WiMAX profile, per operator spectrum unfortunately is very limited. If you look at Verizon and you look at Rutgers campus area, right, within in this particular spot, Verizon probably has 15 megahertz of cellular band, 12.5 cellular band license. Or in the best case, it has about 20 megahertz of PCS license, right? So that amounts to, at the most, one LTE channel, right? So unfortunately, what's going to happen is if you continue to operate in the license band model, the cells in all these layers unfortunately have to operate co-channel. What I mean by co-channel is what is used over here has to be used in these cells also. And all of a sudden then your impedance issues become significant, right? If they, on the contrary, were using independent spectrum, what is used over here is not in use any of the other layers, then I have to deal only with interference management in that thing, right? And that would mean you need more spectrum. So where do you find additional spectrum is sort of the overarching question that one has to ask, right? So solution to all of these things that I've been saying up till now, we are arguing is sort of more cognitive technology. I hate to use the word cognitive, but unfortunately it's already well established when you say something cognitive, people A, first listen to you, and B, they have a general vague imagination of what it could be, right? So we talk of cognitive radio, cognitive networking, and specifically any technology that has a sort of a cognitive flavor to it, right? That is what we need to address the problem. And just to sort of tell you that I may not be speaking your cognitive radio language, because cognitive radio unfortunately is a buzzword, and a good example is seven blind men and an elephant. There was a big elephant and seven blind were asked to go and feel this elephant and describe what this elephant is actually all about, right? And that's what cognitive networking, cognitive radio, cognitive networks has become, unfortunately. So if you are a unlicensed kind of a person, if you are the 802.11 loving person, then you actually want everything to be soft and fuzzy, everything to be free, everything to be just coexisting nice and peaceful, right? And then you are the kind of person who went and felt the tail of the elephant, and it's nice and soft. So you said, oh, elephant is like unlicensed spectrum, right? If you are a service provider who likes everything to be rigid, you like to give guarantees, you like to give guarantees on the coverage, you know when I buy spectrum I have for 10 years, if somebody comes I can beat him up, right? So you felt the big tummy of the elephant and you say, oh wow, elephant is really big, right? If you're an end user, you want again hard guarantees. You pay for it and you want more, something out of it, right? And if you're a lawyer, you want to keep everything in a loop so you can make money, right? But the fun aside, the point I'm trying to make is that the cognitive radio that is often talked about in the academic world is maybe not, or maybe it's overlapping with some other things that we're talking about. All we are worried about is any technique that will improve performance, reduce capital expenditure, operating expenditure. And the radios that we are talking about, they are typically wideband radios. They are typically reconfigurable radios. By reconfigurable, you mean the bands that they operate in and the kind of waveforms that they support. So they could be frequency agile and waveform agile, right? And they could be cognitive based on the kind of functionality they support. And they could be software-defined radio, or they may not be software-defined radio. So all of these things are not necessarily encompassed in a single conceptualization. They are overlapping conceptualization. So our cognitive radio worldview is essentially, you can imagine, a set of these blobs that we are currently working on. There are definitely other formulations of cognitive radio that are out there that we are not focused on. But we are saying is that these are of interest to us. These are the ones that we can show benefits to our customers and to the network that we are trying to build, right? And specifically, the few things that I'm going to try to highlight are these. I'm a little bit colorblind, so if I say the color wrong, don't laugh. So these blue boxes or purple boxes, so whatever the way you see them, are currently the technologies that we are working on. And I'm going to specifically talk a lot about DSA and femto and small cells. A little bit about this. I don't have much time for it, but I have talked to Larry and Wade about some of this in the past. So, and there's a couple of papers also on that, so in case you guys are interested.
So where in this picture of yours is there unlicensed spec? Right there?
Yeah, and a little bit of it can be argued is usable in femto, as you will see later in my description. You find that unfortunate, or?
No, I don't know of any service provider who wants to hear anything about it.
Exactly. So
I'm curious. That's
all of this stuff that we're talking about is in licensed or light licensed kind of form.
So any claim in standardization that anybody's which has times that we are unlicensed providers, service providers as listen according to standards.
No, actually.
No, the other way around actually, because this is not unlicensed.
No, this is not.
I was just making sure I didn't miss the definition of self-X. You're still getting...
Yes, yes. So maybe just to, because self-X comes a bit later in the talk, self-X essentially, X stands for anything that typically you do in the network, monitoring, configuration, measurements, optimization. So self-optimization, self-configuring, self-identifying, all those kind of self is self-X kind of thing. So from a centralized managed network, you're going to a more self-managed network. Self where the nodes are managing themselves, the clients of the network are assisting the management of the network. So essentially, a vision where the human in the loop is taken out, where a Verizon doesn't have to have a team of 5,000 people going around in vans doing measurements and drive testing to make inferences on coverage and call quality and a bunch of that things of that nature. You want to have a network which is architected in such a way that the devices are collecting information that gets aggregated into the network, it's analyzed in some automated way, it's used to do fine-tuning of the network, all those kind of things. So if I go and drop in a new base station right now in the network, the configuration of the network, the tuning of the coverage parameters, all of this is a manual exercise and it's a very slow exercise, right? And in the long run, if you imagine having so-called green networks where the coverage areas shrink and grow over time, right? You need mechanisms in the network which don't require you to do every now and do driving. So the motivation for cost reduction, is sort of this motivation to self-X. So,
And the RF fingerprint that you were talking about, is that also related to the management side or more towards the security?
security as well as to make coexistence of the layers possible. So if you remember, I talked about interaction between multiple layers, right? So the funny interaction that happens is that when you have a device which is ignorant of this hierarchical network, he's passing down a road as an example, right? And the houses on the road have different femtos that are deployed, right? And this phone currently is actually talking to some microcell. But as soon as he enters this block, he starts seeing multiple femtos. And he inherently has no understanding that these are two different kind of layers, right? So he starts trying to hand off because he says, oh, I see a better femto, I see another better femto. So he continuously generates traffic back in the network. And that increases your signaling traffic in the network by like 4 orders of magnitude. So simulations have actually showed that, right? So if there's a way to do smart filtering where you can tell this femto that detect this device quickly and don't generate traffic back in the network. So that RF fingerprinting is a technique that we have proposed, we have a patent file, and we are sort of trying to see how it can be put in practice, where you do localized filtering, essentially a technique within the femto where you detect the device quickly at the RF and phi level and avoid generating traffic in the back end of the network. So essentially, if you want to think of it, a naive implementation generates what is known as signaling storms. So our objective is to bring down the signaling storms by doing quick detection.
So at the femto, you want to distinguish between user that's
He's
supposed
allowed
to
to
connect and the user who's going by.
Exactly.
By
Somebody who's not allowed to use this femto, or you want to be able to filter him out as soon as possible, rather than going to the back end of the network and detecting, oh, this is Ray, who is not part of this house, so I don't want to connect him.
Why does it have to be done at the RF level? Why can it not be done like a policy-based thing at the femto?
No, but you need to have a way of detecting the device quickly, because let's say Ray is living in New York, right? And New York has tons of these row houses, right? And Ray's femto is configured to serve only he and his family, right? So only those 6 handsets are supposed to be served by, right? But unfortunately, because he lives on a dense block, there are in a day maybe 50,000 people passing by, right? And the femto needs to be able to distinguish between Ray's device and your device without having to consult some central endpoint, which typically has authentication credentials.
So right now that's how it is. I mean, like
Yes.
I can use my neighbor's femto if I sort of can see it.
Yeah. I mean, of course, the configuration has to be done in such a way that, so typically in the naive implementation,
I think what he's asking is why isn't there some over-the-air authentication terminating right at the femto?
It's like you have
So
to.
the simple answer to that is the authentication databases are the bread and butter of the service provider. They are typically centralized in a data center. You can't imagine having 64,000 femtocell deployment in a sector in a macro cell, all having pieces of the authentication credentials. At least the providers are very averse to that, right? Because there's a privacy concern, there is a certain owning the customer issue. So these unfortunately become very practical issues which we may not resonate very quickly with. Right?
There's no simple solution like Wi-Fi security.
You don't say Wi-Fi to Verizon.
Okay, I mean, how the access points, like we talk them based on some GWB keys and all. There's no solutions like that.
Yeah, so there is a solution, but the solution is, so WP essentially, there are two versions of WP, right? There's something called shared secret, and then there's something called a AAA based, where the key is actually sitting in the AAA, right? So the exchange has to happen in the AAA for the on-the-air encryption key to be set up.
The enterprise version depends on the radius server that's in that.
So that's similar to that.
So the service provider is essentially the same incarnation, where the remote endpoint is called home subscriber system, HSS. All the credentials are sitting in there, and then you communicate to that entity before you can start sending the key on the thing. So I'm going to talk a little more about now the dynamic spectrum access and sort of ultra broadband calculations. So the femtocells, as I mentioned, are, you can imagine they are like home access points, and the objective is that to they should be supporting in excess of 200 megabits per second. As an example, would be classified as ultra broadband, right? And you already have long-term evolution, the LTE or the WiMAX networks that offer you significant throughput improvements in the macro cell, right? But going forward, you are trying to leapfrog to the next level of per unit throughput, the so-called ultra broadband throughput. And because 40% of the sessions typically originate indoors, as you can imagine from your own activity, most of your sessions are indoor sessions, right? A subset of your day-to-day life maybe is on the street or on the road when you're driving around, but majority is indoors. So indoor spaces are the first place to introduce ultra broadband, right? And typically, ultra broadband sort of would be an extension of LTE and WiMAX, right? And as I mentioned before, all of them use already wideband channels, 20 megahertz of channels, right? So are there enough wideband channels available for an operator? And the answer I said that before was no, right? A single operator license typically tends to be barely 20 megahertz. So you need to get more spectrum. So how do you go about getting more spectrum? And we are sort of proposing two main ways of doing it. If you continue to operate in the existing license model where every operator has its own spectrum, I'm going to give you two examples. One is called aggressively use your own whitespace spectrum. As an example, the GSM spectrum whitespaces. I'll expand on that a little bit further. Then other model is what we call as a multi-operator spectrum. If you are willing to believe that the regulatory authorities like FCC are gradually reducing the regulatory hurdle, then you can go ahead and start aggressively using more multi-service spectrum. As an example, EV white spaces, government use spectrum, or public safety spectrum. Right? Just to give you a quick primer, in the US you have the so-called cellular band and the PCS band. And the cellular band, because it's an FDD system, it has a mobile to base and base to mobile, and it's split into block A and block B. And each block is about 12.5 megahertz. In PCS band, you have anywhere from 5 megahertz to 15 megahertz blocks, and in a total span of 60 megahertz each way, right? And every provider typically gets licensed to one or more of these blocks in a given area, right? So Verizon, as an example, as I said before, most of New Jersey is covered by a block B license, or block A, depending upon which part of New Jersey you make, New York, New Jersey you make, right? If you look at GSM, for example, within this license block that you have 200 kilohertz of carriers that you have divided. If you are Verizon, you have a 1.25 megahertz channel that you have created within each license block, right? And if you are GSM, then that 200 kilohertz again is slotted with 8 time slots. Right? So now let's look at the GSM white space as an example. And this is a very traditional way of doing spatial reuse. There are more aggressive spatial reuse models, but the argument essentially holds true in that case. So if you have cell number 1, the spectrum that we are configuring in the cell number 1 is not used in any of the neighbors if you are doing this traditional 1 to 7 spatial reuse, right? And you can use the same channels again later by repeating that 7-cell spectral reuse. So this is the macrocellular diagram that we have. If you have a tiny femtocell who is sitting in a sector of this base station over here, from that perspective, especially in the indoor setting, whatever spectrum is used over here is potentially perceived as an unused spectrum or as a white space spectrum. So within the same operator's license, roughly 1/7 of spectrum you can imagine is given to each set. So in the best case, a large chunk of your own spectrum is available as white space to be used in an indoor computer setting, right?
Would that not cause interference?
So the assumption is that femto interference as well as femto to macro interference is a controllable entity because of the power as well as because of the shielding that your structures provide.
Is that a fact or is it an assumption?
In simulations, of course, we all know, it has shown that it is marginal impact, and by doing significant power management, you can control those things.
So by
I can send you pointers to the papers that describe the
Yeah.
detailed MATLAB simulation.
But that assumes that you have some sort of non-uniform density of femtocells. If you assume that you have a perfect coverage of the femtocells, then you're in total interference with non-nuclear.
Yeah. So,
I mean, people were doing sort of this fractional reuse and, sort of not having one reuse for the whole system, right? I mean, you
Yes.
kind of dynamically change
Yes,
it
so
depending
this
on
is
what's
a-
happening.
this is-
So it seems like these are all sort of coming back to
Yes.
become the whole
Rehash
structure.
and
This was done, like, I
rehash.
remember, as a student, I would read about this sort of stuff.
But now it's happening for real.
No, I mean,
No, but
nobody,
I mean,
they do it. I mean, nobody does like fixed partitioning and saying fixed reuse and forget about
But
it.
now you can buy your own February, put it in your
Yeah, but I don't think you're controlling this. That's I mean, the
that-
whole point of that.
no,
saying
that's
so I
something-
think his point is partially correct. That's where the self-X starts coming into picture.
Okay, that's something else.
The model is
Right.
that Verizon doesn't really want to deal with coming and installing the box in your place, configuring the box. You just go to Best Buy, buy a box, drop it in there. And there's minimal control in the network where the box registers and maybe periodically does something from the form of command. But
Right.
the operator is not involved in configuring.
Yeah, but given the paranoia that these people have in terms of
Interference.
doing, anybody doing something to their system, right? I find it hard to believe that they will sort of say, okay, here is a equipment I'll give you, take it
Yeah,
home.
I think so,
You're going to
yeah.
use my license spectrum, and then you can sort of screw around with it, right? I mean, it's back to sort of their. I mean, it'll come back and say, no, you're not going to do
Yeah,
it.
unfortunately, you're saying things that we actually observe in
Yeah.
with these people. So when you go into
No,
a meeting
I'm
and
saying
start
it because
talking
I've heard these guys talk about it too, right?
Yeah, so you'll talk about self-X, they say, yeah, we want to reduce our operating costs and whatnot, and we want everything to be self-X. And then all of a sudden, before the meeting, and they'll say, but can you provide me a screen where I can go and look at the thing, then if I want to, I can stop it. Right, so there's a sort of a two-way, I mean, they at one point they will say, yes, self-X should be there and it should be all part of the standard, and at the same time they would say, oh, but we still want some degree of control on it.
So the
But
other
in
thing.
that sense, unlicensed is actually.
But the license is even worse, right? There's no control. I can turn on the
exactly the point.
So,
Good.
yeah, so the question I had is, do they have any measurements of how real femtocell environments behave? In terms of, if I have, like this example you told me about like row houses and near on the street, like lots of stuff. Does it mean that if I'm going to stand outside my driveway and be using my macro cell, does it mean that like my neighbor's femtocell is going to completely kill me? I mean, or my own femtocell for that matter. I mean, how
No,
does
so
that
the assumption
matter?
is first of all, the inter-femto interference, as I keep saying, is a non-issue because of the shielding properties. Of course, it's non-issue, not a non-issue in real scenario, because you could have East London where there's one house here and another house facing that house, and the separation between the two houses is so minimal. And unfortunately, people find the best place to put their femtos in the window. You will have issues, right? And I think,
And they will.
especially, I think East London.
You're one.
I mean, you always hear about how.
Covered,
No,
right?
I always hear about how.
Barbecue,
At least I've heard you guys from Ericsson talk about how in Europe they have femtocell. Right? I mean, people.
Vodafone, so one of the biggest news recently
Right, I was wondering sort of what kind of
companies.
experiments or what kind of results or what kind of experiences we have in terms of actual.
So there is there's sort of guideline that our simulations have shown. They literally took a layout of a typical East London home. They simulated putting this femto in different locations and using ray tracing. They simulated what is the leakage out of the structure onto the front yard up to 15 feet from the location of the femto, and then they tried to analyze if you put a mobile in that front yard, what is the impact in terms of increased interference, call drops. So they did a very detailed MATLAB simulation, and claim is that with reasonable user densities and it's not a significant.
So this people at Vodafone did this? Who did
No,
it?
we did it.
Oh, you guys did it.
Yeah,
I'm
we
sorry.
did. So they simulated the entire few blocks of East London to the fairly good degree of detail, and what they were looking for was impact on metrics like call drop, call completion, the traditional metrics, right? And the impact was definitely there, but it was marginal. And then, of course, we go and try to show that we have these power management algorithms that will help you even bring it down further, right? And these IPs are actually built into our first generation femto product. Is how I understand it. So. But you are absolutely right. Without having a realistic large-scale field deployment, we don't yet know how scalable the co-channel reuse is. Ideally, you would like to have overlapping channel use. But that
Right,
just
because I have to
easy.
tend to agree with what Ivan said. Like if you're saying femto is a concept that's going to be there in every home,
Yeah.
I expect no reason to not believe it's going to be uniform. I mean, the kind of density you will see
Yes.
is going to be sort of
Cordless phone over
uniform.
again.
It's like sort of everybody, sort of. I mean, I'm still not convinced why anybody would throw away their Wi-Fi, given that they already have a broadband wired connection, right? DSL, cable, whatever it is. What is my incentive to buy this femto? I still haven't understood
It's
that.
your phone, right? You'll get a better service.
Your in-house minutes are free, or your in-house minutes are better quality, first of all, right? So how you price that plan is altogether different business question, but I can give you intelligent guesses as to when you are inside your house and you're using Apple iPhone, all those minutes are free, right? So you're not using out of your peak allocation, right? Or if you're willing to pay AT&T $200 and buy this home base station, your monthly iPhone plan could be, instead of $30, it could be $20, something of that nature. All of these permutations and combinations are possible.
But my problem
What
with
makes sense, I don't, as an engineer, I don't know. Answer.
But my problem with that argument is the fact that I can then, it makes more sense for them to give me a limited voice plan. Right? And then I get the same thing without having to have it.
Exactly. So another permutation, as you're saying, is your indoor voice minutes are completely free, and those minutes that you don't use are used for your data, as an example.
Yeah, but that's the catch. As soon as we start talking data, chances are I'll create a lot of interference.
You'll generate continuously large. So it's,
And that kills all the dynamic channel assignment things that we have.
so at the end of the day, you can't have two oranges and try to treat 10 people, right?
Yeah,
So
that's-
you have to have
that's the
some
point.
more oranges.
So, using the self-X self-organization, how are you guaranteeing this, all these hard-limit guarantees which the service provider wants to guarantee? Using all this because now it's going more towards a decentralized thing, and
Yeah.
then QoS becomes very tough.
Yeah, so I mean, we are not anywhere at a point where we can say the network is shifting over to surface. A lot of these things will start at very easy problems first. As an example, the immediate first problem that we are trying to solve in the context of LTE is that when I add a big large macro cell into the network, and I need to, and let's say I assume I'm doing inter-cell interference coordination for better self-edge performance, then my objective is to give different colors to different cells, different parts of the spectrum to different cells. So you want that to be completely self-edge, completely self-configured. And in that situation, it's very easy to do measurements from the mobiles and see how good you are doing. So the very question that you're asking, how does the operator know that the self-X is performing well? All of those things could be actually built into the network, and I'll try to explain to you what is
Because it might be very tough to sell to providers unless you show that, okay, we can do this.
So especially in places like Europe, this is a very good advantage because there are a lot of GSM operators, second tier and third tier, who have spectrum allocated to them, but they don't have any 3G spectrum. So they don't have a means to offer data services. And increasingly they are realizing, as I said, the voice R2 is very static or declining, right? So they want to offer data services, but they don't have spectrum. So unless I go and spend billions of dollars getting new spectrum, I can't offer any data services, right? So lo and behold, I can use my own spectrum and at least offer indoor or data services, right? Then I have some way of generating additional revenue. So our pitch is that this kind of thing could be a very good way to evolve from existing GSM to eventually long-term evolution kind of LTE networks. So a simple example, if you take GSM, I think the concept is probably very much clear by now, right? If I put a femto here, this femto is getting all the channels that are used by the macro that it is embedded in, right? And unfortunately, for the femtocell to figure out what is currently used in the macro cell and what is not used in this macro cell, so what is used by its neighbor, it's a not trivial exercise. It's something that you can't easily configure statically, right? Because of the notion of frequency hopping that is often built into GSM. So you potentially need to do spectrum sensing within the femto to be able to figure out these in macro cell and in femtocell sets of frequencies that you want to configure on the fly. The next concept that we are sort of exploring is what is called as spectrum pooling. The term spectrum pooling has been around. Here we are specifically talking about multi-operator spectrum. So each provider owns his own cellular and PCS bands and uses them in a microcell. But if you have a femtocell that is deployed in a region, this femtocell has not only access to your own spectrum, but it has access to the entire band. So if it's a Verizon femto, he uses not only the block B, but it also goes and uses block A of the competing provider, as an example, Sprint, right? If you combine multiple such bands, the cellular band, the PCS band, the IMT band, the spectrum pooling will actually create large number of spectrum. And all of a sudden now, the problem of assigning spectrum to a large pool of femtocells becomes somewhat manageable, because at least at your disposal you have more oranges, right? So to illustrate that point further, the planes that I'm showing are the macrocellular networks of different operators. If I look at Murray Hill, Verizon, for example, owns block B there and block C and F in that region. Provide a singular, meaning AT&T owns block A in cellular and PCS block A again, right? And similar and so on, right? Now, if I look at a Verizon femto, that uses not only these 3 blocks, but it also goes and uses all the other blocks. So all of a sudden, you have increased the amount of spectrum that is at the disposal of the femto. And because you have more spectrum, you can do wider band channels, and that leads to better throughput, right? Better capacity. And if you look at, if you are following the industry world, already there is a trend to what is known as pairwise pooling. So if you know, in Europe, Vodafone and Orange already signed a deal which allows them to pool their radio access network resources. So they already do what is known as band share. So doing spectrum pooling is a very natural next level of evolution, is what we are trying to argue. And because you're doing it in an indoor setting, again, the problem could be not self-contained, it could be a contained problem where the impact on your broader macrocell could be limited.
So Vodafone and Orange are doing it in the context of just macrocells?
Macrocells,
Okay.
exactly. So instead of buying their own sites and deploying their own base stations, they actually agreed to do quote-unquote radio access network sharing. So there are already so-called roaming agreements, but the roaming agreements are often meant only for filling in capacity holes and coverage holes, not for a really large amount of throughput sharing. So unlike in case of branch sharing. So in addition to the multi-operator spectrum pooling, we are saying that you can go ahead and start using other people's spectrum, which of course is a little bit of a strange notion for a service provider, because they are used to paying for the spectrum, owning it, and they know that when I pay, I have it for 10 years, so to say, right? And a lot of the so-called unused multi-service spectrum that we are talking about, whether it's TV, whether it's public safety, this government spectrum, it's not completely unused. It typically has utilization, but it has a low factor. So at any given point in space, as an example, the public safety spectrum, right now there's nothing happening around it, right? So that spectrum is highly underutilized. So you could have a Verizon factor sitting in this building which opportunistically uses that spectrum. But as soon as there's an emergency, he quote-unquote walks away from it because there's a siren blaring. When a cop car comes, you get out of the way, that kind of a scenario, right? So if I'm able to do that, and if I'm able to do it in a reliable way, without impacting the primary user, again, I'm increasing the pool of spectrum that I have available, right? But the natural resistance from the service provider point of view is that they can't put any statistical number or guarantee on it. Ideally, you should be able to tell them that here is 50 megahertz of spectrum. I can guarantee you that 90% of the time you will have the spectrum available to you. And once you have it available, it will last, the availability will last for X number of minutes or hours, right? When you make that kind of statement, only then they know how to dimension their service and how to dimension their revenue estimates and whatnot, right? So you need to be able to provide certain characterization of statistical nature of this appeal, right? So currently we are hoping to sort of provide answers to those questions. So just to give you a quick highlight, and maybe all of you guys are already familiar with the TV white spaces, but just a quick illustration. what we are showing over here are the coverage areas of different TV stations in and around the South Atlantic City, Philadelphia area, right? So if I look at femtocells 1, 2, 3 that are deployed in an area called, I forget the exact location.
Cumberland County.
Huh?
Cumberland County.
Cumberland County, and the TV station there typically uses channel 36, RF channel 36, right? From the point of view of these femtocells, this is of course a no-no because that channel is in use. But if I look at channel number 44, which is used in Philadelphia area, this guys potentially see that as an empty channel because the TV signal coverage area is only up to end of this service edge contour, right? So as you can clearly see now, each of this TV channel is 6 megahertz, right? If there are a bunch of these TV channels around, I have again a large amount of indoor spectrum that I can put to use, right? The implication of all of this is of course that, maybe I'll first go through this quickly. So what does it mean from the point of view of the air interface and from the point of view of the RF that you have to implement in the base station, right? First of all, if you look at the GSM white space, right, each of the channels is 200 kilohertz. And the colored carriers are the ones that are currently in use in the given macrosystem, right? And if you have operator license of about, let's say, 12.5 megahertz, you have 62 GSM carriers at the most at your disposal, or up to 75 in the BCS band, right? And similar numbers are valid in Europe also, right? And if I allow you to do multi-operator sharing, then that number can go up to 300 GSM subcarriers, right? A fraction of those are used in the macrocell and rest are usable in the femtocell, right? Now, how many of those carriers are available to you? It depends on the frequency use pattern, again, that needs to be dynamically inferred based on the location that you are in, right? So, let's say out of 300, even 100 carriers are available to you, subcarriers. You have 200 into 100, that much of a spectrum. All of the spectrum, unfortunately, happens to be non-contiguous in nature. Because, as you can see, the first white space is over here, the next white space is over here. So, no longer your air interface and the RF electronics operates assuming the spectrum to be a contiguous spectrum, right? If I go to the TV channel, the same kind of situation holds, but each channel is significantly longer, right? Because you have a 6 megahertz channel. Typically, in the US at least, adjacent TV channels are not used in a given space because of the interference consideration and because the receivers can be very down, right? So often you will find that the adjacent channels are empty, right? So at the very minimum, you could find 12 megahertz spectrum, but separated by 6 megahertz device solution, right? So your white space is again non-contiguous. But in this particular case, you may not be interested in exploiting these two bands in a single air interface. You may want to use them as independent channels. As an example, if you have LTE 5 megahertz profile, FP for WiMAX 1.75 megahertz profile, you can activate those conveniently in just the 6 megahertz channel that you have, right? As I said, I think...
So these are like self-activations, right? The device locally is going to
Going, exactly.
And you might buy a lot of devices that make this kind of determination, right?
Yeah. So the coexistence is definitely an issue where you need coordination built in at that level too. Even at the sensing level, you have to be coordinated to ensure that there is no secondary transmission going on. Non-trivial things that are in there. And in this particular talk, I'm trying to sort of give you a view from the top down. And there are more experimental things that we are currently working on that also. Ivan, you had something?
No.
I think there was a piece of work that Joy did on non-contiguous work symbol synchronization. So that actually was of relevance to the kind of things that we are talking about here.
So is there a reason why operators prefer this mode to just license? Why is this white space mode relatively to them?
It's not clear it is.
It's not clear it is, yeah. So
I
the
don't know,
simple
I mean,
answer
do you know
is-
something? I don't,
know.
I think they don't care about
No,
that.
but that's the 5.5 piece.
Not the operators, they don't want, if you look at the auctions,
But for the operators, I would claim the worst is to use their own spectrum.
That's what they're all doing.
They're probably reducing their own wide area capacity, which is their bread and butter. So
See,
you
the
can.
point I'm trying to make is that your current disposition is, your current behavior is based on your history, right? So unfortunately, your history currently says that I can dimension my network carefully, I can get $10 billion worth of spectrum and I own it and everything goes hunky-dory, right? But AT&T is already experiencing that the more iPhones you sell, the worse network performance experienced by the end user is. So there is no magic to it. At the end of the day, you have to go and add more.
no, so that's good. See, unless something like that happens, right? I don't think those guys are interested in sort of.
No, I'm sort of questioning. I think that the basic fallacy here that if you start introducing a lot of decentralized service in your own spectrum, you might find random variations in quality which will be very hard to control, especially if you care about worst case.
Yeah, sure.
But if at the same time you should not be opposed to using other kinds of spectrum. Unlicensed seems the cleanest form of spectrum.
Unfortunately, no, I don't know why it's different.
But I don't see
because,
shooting yourself in the foot is any better than using somebody else's stuff.
Oh, so T-Mobile's at home is a good example.
Yeah.
I mean, it works fairly nice.
No, but they are using the Wi-Fi. You know, the phones now do Wi-Fi when they can. So that is.
Verizon is not benefiting from the Wi-Fi phone yet. But the question is, how do these operators think about
So if T-Mobile tries to sell this, unfortunately,
I
it's
know,
not
but
very successful.
Mobile definitely they have a home base station that is 32211 enabled, right? There's no
And it works
phantom
like
enabled to it.
There's no phantom or nothing, it's the Wi-Fi. And it can work anywhere, here, home. It's actually a fairly nice concept in the sense that when you
I
switch to
think
Wi-Fi,
you're sort of overlooking the point that the current deployment of WLANs in 802.11 is essentially a very sparse deployment. If you start thinking of a dense deployment, the kind that you're talking about, 802.11 breaks down and then all the nice claims about the throughput go out of the window.
So that's all true, but my claim is that the macro plus femto, it's not clear how it's going to perform in worst case. I think you can do some
Very true.
reasonable analysis.
You're right. I agree 100%.
And if they have a certain revenue, most of their revenue is for wide area mobile coverage, not for in-home.
No, but see, that's increasingly going to change as they are experiencing that the revenue growth actually happens through e-video subscription, right? Every quarter they report that their e-video is going up, right?
yeah.
And lo and behold, so maybe I'm saying something I shouldn't be saying, but the fact of the matter is that Verizon publicly made a statement that if a large portion of their 80 million people come and start using video, they do not have built into the network, right?
But that's the same thing with
And
AT&T.
AT&T is merely selling iPhones, right? Because for whatever reason, their network is not dimensioned to handle iPhones. So a lot of people complain in New York City when you open an iPhone, it barely gets any service. Right?
So therefore, you're saying they are interested, or are you saying they should be interested?
They are interested. So
They are interested. Okay, that's good.
Vodafone, for example, has a contract that they recently announced where they will buy campuses from us and another competing vendor, where the first generation campus will be deployed in HSP.
And that's all, and I think that WINLAB, this point has been made for over 10 years before I came here, that things won't scale and you need this opportunistic access. But my only caveat is somehow I don't think it's right to do it in your own unlicensed, and maybe the operators should get together and build a
Pooling,
common
so that's what we are
unlicensed
saying.
band
Spectrum
of
pooling.
Yeah, but the spooling idea has been floated for like 15 years, right? And so they just, because they are a competitive advantage. I think you're saying you're having better coverage than somebody in some area. Then you're saying we'll all go pool.
Simple example is unless the gas price goes above $5, you're not going to talk to anybody about sharing the card, right?
You still don't.
No, but
That's something I won't do.
so the tongue in cheek is that there's economics involved that will force you to do research sharing, right?
No, so it's good. I'm saying, look, I'm all for it. I mean, I want that to happen, right? And I just don't see these guys really even sort of being remotely interested in this sort of stuff.
But I think the 5G plan right now is clean enough, they can use it for 3 years and nobody will complain. But they don't want to do that, so that's a bit of a strange, psychology.
I have gotten this argument a lot from you can get scenarios saying there's plenty of stuff up there, why don't they use it, right? Why do I need to go and use it? Other than business reasons, I'm not able to say anything why they don't. Because just the notion of unlicensed is something that they seem to shy away from. At least the top tier providers seem to shy away from.
Yeah, but the world changes as we speak, you know. Like, so everything is changing, so why don't they accept and just call it something else?
That's my problem.
Shared common.
See, at the end of the day, it's all about control of some kind, right? You have to have some notion of control on what you're selling and
I
what you're
think our
charging.
question in the back here.
Yeah, sorry.
Why is it that the white space is viewed as different from the unlicensed?
I mean, I don't understand, to me, each one has its own peculiarities, but they are unreliable.
Oh, so I'll tell you
White
what
space has again guarantees of sorts, right? Because unlicensed, there is absolutely no worst case guarantee, right? In a dense deployment, you can have turns up, if there are 100 access points, the 101st access point can be
So,
deployed.
well,
Wait a
white
second,
space, so
we're
how is
training
it different than
CSMA
white space?
for primary
Say that
detection.
again?
How is
That's
it
the only-
different than a generic model for white space?
Yeah,
It isn't.
no, there is.
Well,
That's the, I don't see, I mean, once I occupy a white space, it's empty. Other guy cannot.
Yeah.
So
I
how
mean,
is that
spectrum
different from
coexistence,
CSMA?
there is nobody's talking about spectrum coexistence in white space. How do two secondaries interact? No, they're not
Exactly,
even
there
worried
is
about
no,
it.
that's the thing, and
That's
that's
all.
the same thing as white space.
In our
Just like
license.
unlicensed ban.
There is no difference.
In our formulation, there's still some coordination going on to ensure that people are not stepping into the same thing.
How can you
How?
stop that? No,
I mean, like,
you may have coordination
Verizon
amongst your
can
devices,
sell and T-Mobile
but if
can
something
sell.
else comes along, what can you do?
So if it's a pooled spectrum, you can do it by doing interoperability.
Wait a second,
No.
I'm church microphone. I have nothing to do with.
Yeah, he's saying a white space. He's not
Church,
talking about
white
full
space.
spectrum.
church microphone requires you to walk away.
I mean, this is sort of what the classic
It is that's the standard requirement, right?
So that's the same as a license.
So right now,
If you
No,
I see you have
not
to
in
walk
the
away.
sense church microphone comes on only once in 7 days. For the 6 days that I'm there, I can still use it. Right?
That's
No, no.
assuming that nobody uses it. Because
No,
the
but
white
the
space is
advantage
not popular.
the
Everybody will have
advantage
a
of
white
this
space.
model is that I have always something to fall back on, right? In the worst case, I have no white space. I'm sitting in my own
fine.
space.
So
If
the
you're
same as
operationist-
unlicensed.
Huh?
The same, if unlicensed is gone, I'll switch back to the.
No, so I'll tell you, there's one difference, Stefan, in terms of physics. Right, if you really think about the 700 megahertz spectrum, your signals can do sort of more in terms of the distance they can
They can do more damage.
Okay,
yeah.
then sort of, so therefore I think if you, I talked to the guys at Qualcomm.
It's worse.
Buddhikot. Huh?
It's
So white
worse.
space is worse.
White space is
No, no,
worse.
so
Signals propagate farther.
Much farther.
Right, so therefore they're sort of saying, the guys at Qualcomm, at least their view, right? The few guys who sort of work on this,
Yeah.
their view is that they want to sort of engineer systems that are between 100 meters and 1 kilometer. So typically you think of cellular as a kilometer, right? And you sort of engineer it for that. Then you think of Wi-Fi or unlicensed as sort of 100 meters. So here they want to keep it in such a way that it's sort of in between. You're right, you don't want to go, because things can propagate further, you can cause more
700.
interference. So they want to do power control, interference cancellation, all that stuff, and sort of operate in a regime where you're sort of in between these two. But then again, spectrum coexistence, I mean, it's like, we're back to all the good old,
They all
CSMA, we're gonna do CSMA.
They all assume they're the only user of that.
no, so these guys do talk about some spectrum coexistence, but you can provide no guarantees, as
So
everyone
there is-
says.
then
I mean,
reflect on
if
what-
somebody, you and I decide to take a device there and do something, nobody can do anything for us. I mean, assuming we have registered with a database, followed some rules, done all the things that the 8.22 requires us to do. We do all that, but then we can go completely sort of disrupt everything else. So he's saying, opportunistically I will use this, but when things are bad, I will go back to my license.
So there's a sort of gradual evolution if you want to think of it. The spectrum pooled model, where multiple operator spectrum is pooled, can be very tightly coordinated because
That's fine.
Yeah,
License spectrum, you can do what you want. Fine.
Now I want to go even further, and I have other people's spectrum, right? And I use it when it's clean. If I sense it to be clean, I use it, right? So it's like increasing from 20 megahertz to 250
But
megahertz.
That's CSMA.
But Ivan's point is structurally,
Then I
right?
use it. I mean, there is
Yeah.
no difference whatsoever.
Based on your
It's time scale.
disposition, you can either operate here, which Verizon currently operates. If you're a little bit more liberal, a centrist person, you could go and do pooling with somebody else. But you still know that only Westfield people can come and play in the Westfield garden. So to say, it's a license control thing, right? But then you can go to another model where the far end liberal model, tragedy of commons. Anybody can come and put anything you want, and you have to unfortunately take it, right? So if your operator model is, I can take from here to here, then you have 250. If you are willing to take this too, you have 100 megahertz. If you are not happy with this also, you have 20 megahertz. You live with what you choose, right?
No, that's why I'm arguing we should choose everything. I mean, there is no reason.
I think the T-Mobile example he gave, right? Sometimes already using unlicensed opportunistic
Same thing,
account.
just choosing
Right, I mean, it's bad, it's bad. So, but
So
when it
can you charge for that service, right?
that I think,
No,
that I
they
think
can't.
actually,
So that's the whole point. Once you're on the Wi-Fi, they say it's yours. Do it.
I know, but then there's no output to, right? It's like, why would I bother? I mean, it's like, as if it's not in my portfolio of services, right? If I'm a service provider, my objective is to increase revenue, I need to find a way to tether you to me, right?
No, but then
So I can't
that's-
operate it unless I charge you. That's a simple
But that's the
premise.
same as, hotels give Wi-Fi for free now, because that's their, nobody wants to go to a hotel that doesn't have Wi-Fi. So the same thing is here.
I think
If they don't give me Wi-Fi, I
There's a
mean,
little bit of mismatch where I'm coming from. I'm coming from the people
I
who
know.
want to make money on the network, right?
I know, yeah, yeah,
Coming
yeah.
from the customer who doesn't want to pay.
exactly. So that's, I agree with you.
No, I mean, but
That's,
I
I think
think
that's the
one's
whole.
side is stronger.
Huh?
I mean, like one side is stronger, right?
But you get what you pay for, right? I mean, at the end of the day, there's no graft.
Sure. That's why Skype
no,
was sold
but the
for
thing
$2
is, right,
million.
if these guys like Verizon, the guys you talk to, are really sort of seriously interested in understanding how they can use this white space in an opportunistic way, I think it's good. I think it's good in many levels. Because otherwise this whole cognitive radio
No, I
experiment
think
is
what
just
we are
going to
saying
go
is
away.
they won't be interested unless I can make the following kind of statement. You will get this spectrum, you'll get it 90% of the time, you'll get it for 30 minutes.
You can't do that.
No, statistically you have to be able to tell them. Only
I
then
think
they
that's
will.
the point. I mean, white space is
No,
like
because they understand, they only understand guarantees.
yeah, so then they have to think about new metrics.
For data service, they should care more about averages. Right?
Yeah.
I mean, if I have a million iPhones to serve in New York area and it happens that 589,000 get served by a hotspot, and I really don't think it matters whether it's a Wi-Fi hotspot or a white space hotspot.
But you know who's going to screw them up? Apple. Apple is going to come up very quickly with a solution where they will recognize there are more Wi-Fi and they'll start switching traffic to Wi-Fi, and then very quickly they'll say,
No, but I
well,
think, see, again, you are the feel-good, I'm holding the elephant's tail kind of a person, unfortunately. Because despite the claim that Wi-Fi is a nice, inexpensive solution, I don't think dense deployments will hold up. To the extent that you want the coverage to through.
It's as dense as it's going to get, right? I mean,
New York, I mean, if the kind of scenario that I tell you, with a block, multiple row houses, all of them deploying I doubt it will give
They
you.
all have it now. I mean,
Like, okay, they didn't Marco tell us that in Times Square they saw how many 400, 4,000, 400 access points. I remember Marco telling me.
Ali is here.
I mean, we don't want to.
So these things were not killing each other, were they?
They were, but that's okay.
Yeah, but so did you know
No,
what
but-
user statistics?
So now we're talking millions.
Let him go back to the top.
Yeah, sorry. No, look, this is a sign of really good talk.
So this is what we are currently sort of exploring and implementing is this architecture where you have a notion of an entity that sits in the network. We call it this sort of collaboration sensor and a spectrum server. Each of these femto base stations essentially contains a spectrum sensor. And you can imagine that you have a spatio-temporal sensing data that is being continuously sent to this collaboration sensor. So the two components, as I mentioned, in this femtocell are the spectrum sensor and the non-contiguous VOIP air interface that you have implemented. Now, within the spectrum server, you have algorithms for deciding how to combine the different sensing measurements that you have received. Based on that, how do you assign the spectrum? So there's a notion of assigning spectrum to these femtos such that they don't step on each other. So that's where the coordination comes into play in our case, where if I'm using the white space, the next guy who's using the same thing who falls within the view of that white space is likely sufficiently far out and segregated. So the problem that 802.11 will face, uncontrolled, uncoordinated deployment, is not going to be there in our situation, right?
Assuming everybody is part of the same spectrum, so.
Yeah, in spectrum pooling, it will be very easy to do in terms of certain kind of white spaces. If the regulatory authorities allow it to be licensed or lightly licensed, as an example, 3650 band, which is non-exclusively licensed, whatever that means. Non-exclusively licensed is before you use it, you have to register with somebody. So that somebody knows who are the current number of users in that map in a given location, right? So that gives you ability to do admission control if you want to think of it in simple terms, right? Unlike in unlicensed.
Somebody has to start working on denial of service attacks against the server. This is big money.
Yeah, but this is in the Verizon
Bring
network.
down the
So,
radio network.
if you are saying Verizon's home location database register is
Yeah, it's the same
it's
thing.
a great resource, right? Is it experiencing any denial of service? I'm sure it's facing.
Yes.
Is the Verizon network still running? Yes, it's running. So something can be done about it.
No, I agree. I'm just saying, as a research topic, it's
Yeah,
interesting.
definitely. Because you can fool the Spectrum server and get the
Yeah, just sort of claim the resources whenever you need them,
Yeah.
or whenever you want.
And the end user devices, of course, have to handle the new air interface. In our conceptualization, we are trying to keep the handsets completely out of the sensing loop. We are hoping that they essentially are simple devices with modified air interfaces without any additional functionality for spectrum sensing.
But they have to have a non-continuous RPM.
Non-continuous. That's right. So these are the two pieces that currently we are working on. The NCYFDM stuff, we have started our work, but the system implementations are nowhere close to any kind of maturity, I would say.
The receiver design is quite complicated. Choice,
Yeah.
blockage.
So even the basic symbol synchronization is a non-trivial thing to do as.
So this NCOFDM, I saw a demo by a MIT grad student.
Yeah, Rahul Hariharan.
Yeah, is that the right direction? And do you see some, for an engineering solution, is there some bigger thing to be solved?
So in his case, he didn't, as you were just pointing out, even the basic issue of symbol synchronization, he didn't deal with any. He just did the simpler part of it, so-called nulling out the 50 subcarriers. And even Joe Evans' student, Rakesh Rajmanshi, he had a thesis on non-continuous RPM, where he explored some of these things in their Kansas City, their other
KC radio.
KUAR or something.
KUAR.
KU, Kansas City ATL radio. So he worked out seriously.
Synchronization is the big issue.
One of the issues, definitely. And then even conveying the subcarrier nulling mark.
Not only that, right, the other issue is PAPR becomes an issue again.
Peak to average.
Because you're doing sort of
Yes.
non-uniform loading, so the whole,
The power amplifier requirements. The assumption is that in femto it's less of an issue, hopefully, right? Because femto, the peak power limitations are less than 200 milliwatts, right? So the linear,
Yeah, so it's much easier to do the
much easier to do it separately. So it's almost like you are dealing with something that can be tackled and is somewhat contained. And there's also a notion of a cognitive pilot channel. In the interest of time, I'm going to kind of rush through. But the cognitive pilot channel is essentially supposed to signal to the end user device what spectrum the femto base station is currently active. So currently, let's say I'm active only in the operator spectrum. Then I find that there's a widespread spectrum available, and some of my users are going to be shifted. So I can signal through this pilot channel to those two handsets that thou shalt transfer over to the that kind of signaling can be done through that pilot channel. And again, these pilot channels could be nicely implemented as logical channels in the existing 4G air interfaces, because you already have a channel to the end user device. So having your own infrastructure, having your own air interface to fall back on gives you nice ways of doing things. Unlike in unlicensed, unmanaged commons, where the model becomes full-blown uncontrolled, right? There's no connectivity, there's no coordination. Devices are just coming together and doing things. So, so I already said that, all of this stuff, that each of these sensor becomes a distributed sensing element, and essentially the collaborative sensor is creating a spatial map of sorts, and also coordinating how this sensing happens. So you don't need to have all of the femtos doing simultaneous sensing. You could quote-unquote create affinity clusters, and within the affinity clusters schedule nodes selectively at different times to minimize the sensing load, right? So how do you go about doing these things? So we have some ongoing work. There's some intern actually from Suman Banerjee's group currently working on these things with us. And then we are exploring some of the soft data fusion, hard data fusion. Let me quickly show you the experimental system that Ivan is already greatly familiar with, and he has his fingers deep into this IP understand. So, but essentially it's a three board stack with the RF board, the digital board, and the FPGA board that we have. And we have interfaced this thing to, it's the same thing as what you guys have.
Yes.
So it's actually, unfortunately, you are not supposed to get impressed by this. So what we did was we actually interfaced this thing to MATLAB as well as to GNU Radio. So we implemented, this diagram is also familiar with you. So it basically looks like an IP device to you at the end of the FPGA through the Ethernet port, right? And you're sending all the INQ samples and IP packets coming out of this Ethernet port. And you write an adapter so the INQ could be pushed into the GNU Radio software stack. So we did all of that. And this also you guys are familiar with. And we essentially implemented an energy detector using this device. And then we implemented sort of thresholding schemes to detect white spaces. And then each of the sensor, then multiple of these boxes, we are essentially writing a collaboration server and combining these measurements, right? So this was our quick example of setup. We have two boxes together acting in the front base station. On the left is the spectrum sensor, and on the right is the secondary transmitter. And currently we are using, in this particular photograph, we are just using a signal generator, but we have started playing with sort of 8 to 11 access points right now to detect more real wideband signals. Huh?
So this is again just narrowband sensors, right? Or are they wideband sensors?
So currently the box is capable of processing up to 22 megahertz of chunk at a time. So you can do quadrature sampling at about 25 million samples. Currently in the box we do that 25 million samples per second. Maximum can do 64. So right, 64 is the chip I remember maximum. So and at 25 mega samples per second, the incoming data rate over the Ethernet is about half a gigabit per second. So unfortunately, no laptop, I mean, no even good solid multi-core CPU, I don't think can keep up with it unless you have some sort of real-time support in the right. So the talk that actually Dirk gave in the review, the kind of multi-core processing of RF is definitely of great interest to us, and but how soon that those things will happen is very hard to know. So even though we have done this in GNU Radio, our current effort is all putting everything in the FPGA. So this summer actually we have the FFT-based thing in hardware also working. So if you guys come by maybe in August, I can do a demo of that thing to you. So this is just a simple example of how the channel switching algorithm works. In this case, this is a simple primary that we wanted to show you. This is a two-tone secondary, and it's directly separated in spectrum, right? And then as we start moving the primary closer to the secondary by increasing the frequency dial, the secondary essentially shifts over. So when the primary came close, the secondary shifted over to a different location because the sensor was able to sense the appearance of this primary close by. And then again, we did a similar, you again brought the primary back, secondary shifted. So you can do this kind of scanning through total 300 megahertz at the ISM band right now. So this board currently operates in ISM and Uni and the 4.9 gigahertz band. And sometime in next 2 weeks, Peter is going to give me another board that covers 400 to 900 megahertz. So we'll be able to actually play with the whole frequency range of that.
This switching happens in software?
Yeah, currently all of that happens in software. And also we are actually working on instead of the secondary transmission being just a simple tone that I showed, we are working on a 2 to 11 like stack that we are implementing. And at one point I remember Ivan had told me that his students had already implemented that stuff. So it's probably in my interest to work with the students if we can make it work. So maybe I'll just quickly go through this. Self-X and microcells, that's another work that we are currently doing. Here the problem statement came from actually how do you do self-configuring macrocells? If you throw in a new macrocell in the network and it has to be configured, as I said before, it takes a significant amount of time. Instead, can you make this completely self-organizing, right? And X, as I said, is configure, monitor, correct, and optimize. And the self-X, the selling point is you're eliminating the human in the loop, and it potentially gives you better scalability, faster response time, and higher performance, right? And we are interested in realistic technologies that can be deployed in the next 3 to 5 year time frame. Right? So to give you a quick example of the specific problem that we are addressing is the fractional frequency use that happens in the DMA network. We want it to be fully self-organizing. So you have example of 3 base stations where the full, let's say operator license is 20 megahertz, right? The whole 20 megahertz is used in a certain part of the base station coverage area, closer to the base. But to improve the cell edge performance, the cells out the coverage points out of this circle are typically, when the user is in that area, the user is given smaller than 20 megahertz as an example amount of spectrum, right? But the key thing is that the adjacent cells all have to use different parts of that same 20 megahertz, so that the interference that is seen by end user devices in those edge areas is minimized. So essentially the fractional frequency use improves your cell edge performance, right? Now if you have femtos also deployed in that region, you can imagine that the femtos actually will be able to use even more aggressively the available spectrum, right? So there are 2 things that need to be automatically configured. What spectrum do the macro cells share amongst themselves, especially in the case of addition and deletion of cells? And also when the femtos are added in the another layer of the hierarchical network, how do they go about figuring out what portion of the license spectrum they should put to use, right? And this problem unfortunately has to be done with certain constraints that you have to satisfy. It has to be completely distributed, and it has to be dynamic in the sense if the femto decides to go to sleep because nobody's in the house, but he wakes up and somebody comes in the house, there's a notion of things changing in the network constantly. There's a dynamicity in the network, unlike in the old network where once the base station is deployed, it typically is there, right? So the algorithms that we have to be able to really handle inserts and deletes in a way, right? Also, if your air interface is able to handle contiguous spectrum versus if it's able to handle non-contiguous spectrum, it has tremendous implication on how complex your algorithms are, right? And also your allocation needs to be completely, ideally conflict-free. If it's not conflict-free, it increases the interference floor in that select set of cells, right? So just because the spectrum is limited, if the number of base stations goes beyond the limit, you may not be able to do conflict-free assignments. Then your objective is to bring down the interference to the acceptable levels, right? And also, every base station in our judgment should have at least a minimum amount of guaranteed spectrum allocated to it, right? So, lo and behold, satisfying all of these things becomes, in one shot, becomes of course a very hard problem to solve. So, we see this as essentially dials that we can control. And we have done actually very good. Oh, so one more thing is that the dynamic nature of this situation. So when I drop in a cell, if I had to change something in the neighboring cells, how far does that effect cascade? If I put in a new base station and if it's going to require reconfiguration in the entire North Jersey area, that's not a good thing to happen, right? So this notion of containment effect or cascading effect will be limited, right? Can we make strict guarantees to the provider that if my algorithms will guarantee that only the 3-hop neighborhood will be affected, only 2-hop neighborhood will be affected. But making such guarantees has other implications as to how optimal your solution is, right? So we have actually worked on developing these algorithms, and currently we are implementing these things in a LTE simulator. So if you guys are interested, I can provide you more detail.
Could you
One-
please repeat your point? Why this allocation to the baseband have to be contiguous chapter of the spectrum, but before you said the non-continuous or the
So yeah, let me explain that point. So what I was saying was, if let's say there's a mobile over here, right? And currently this mobile is talking to this particular base station, right? And to minimize the interference seen by this guy, this base station is going to use a non-overlapping part of the spectrum, right? But now, if you put the requirement that the spectrum that this base station uses and the spectrum that this base station uses has to be contiguous in nature, then essentially you can imagine that it's a packing problem. If you have these contiguous chunks that need to add up to the total spectrum, the number of combinations that you can do are fewer in number versus the case where you can just pick and choose at random different chunks.
Okay, so this is out of concern for complexity, not
Yeah.
total.
Yeah, but what the device supports, if the device supports non-contiguous interface, your life becomes easier because you can give non-contiguous chunks to the base stations, right? So not supporting non-contiguous spectrum means the algorithm designer has to work harder to be able to do color assign, right? Another last problem that I'll mention, then I'll go to the end of the talk. Specifically in the context of the femtocell, we are looking at this problem. Imagine this particular building, right? You have offices all over the place. Each of this room has a femtocell deployed, right? And you have an omnidirectional antenna that you have put into on each of these femtocells. The omnidirectional will guarantee that in certain part of the coverage area there is undue interference, right? Instead, now if I go to a more directional model where the antennas on these base stations are switch beam antennas, directional antennas, and I'm able to create a nice, of course, in theory, coverage pattern of that nature, then the aggregate capacity that you will see in this network, we are arguing is going to be better than this, right? And we don't want to be doing this in a static fashion because there's a traffic dynamics in the network. As the people move around, I may be interested in improving the coverage in different parts of the building at different times of the day, right? So I want this angle of the antenna to be dynamically selective to be able to play with the coverage.
The problem is when you have directional antennas indoors is that there's so much multipath that you
Yes.
cannot predict where things are going.
Yeah, so the clutter effect that definitely people have asked that question, and you're right. How to address that? Right now, it's almost like the algorithmic piece is different, but in a practical setting, when you do this, they have the multipath effects. Right? So I won't claim that we have made significant progress in this problem, but this problem was posed to us, and we sort of started looking at it. So part of the purpose of my talk was to show the things that we are working on, and of course, see how if there's interest in these problems. Right? So we are interested in having this antenna assignment, angle assignment, to be done in a sort of a distributed fashion in a given femto population. Let me skip. I had more slides than probably I. Okay, so this last piece of thing that I wanted to come to. Here's sort of a paradox in my opinion. And of course, because I'm working on it, I believe what I'm saying is interesting, which may not be necessarily the case, right? So, right. So what I'm saying is that the problems that we just talked about, we believe that they are interesting problems, right? But the paradox is that you have a cellular network which has an $800 billion revenue. You have a 8 to 11 market which is about annual 4.9 billion, right? There itself there is a size difference in terms of impact, if you want to call it, right? Economic impact. If you go to any IEEE conference, InfoCom or MovieCom, the number of papers you will see on WLANs are about 95%. The number of papers that you see on cellular, maybe 0 to
Because none of them is published, they have patent everything and they don't want to.
I'm coming to that. It's more the rhetorical argument all I had with Ray for the last 10 years, but I always like to bring it up again and again. So why is that the case, right? The excuse generally is that cellular is a closed technology, right? The exact thing that you said, people like to patent, right? But my contention is that going forward, there are so many problems. As an example, self-fix is a very good problem where you are not bound by any technology, right? You understand the technology, you can come with your solution. And there is exciting stuff to do and prototype there, right? So why is it that we do not see involvement of academic community jointly with industry people exploring these things, right? And I'm saying that generally in the academic community there's a bit of a bandwagon effect, but this is where people like the graduates can make a difference because you guys are the thought leaders, right? You are the cream of the crop, raising the largest amount of money and for the best centers, the best students in the country, right? And you should be able to make the difference.
So a partial response to this is actually about 40% of our portfolio is cellular or generic cellular, like OSD based or spectrum CN.
Yeah.
The pure 802.11 is actually going right here, but the ACM conferences, I would agree that
increasingly it's becoming like
mostly 802.11 based, but that's a different culture of taking an open platform and do something with it. So if these radios become available, maybe you'll see some changes.
Yeah.
But that's true.
So I'm trying to understand your number, right? So 800 billion is what, and what is 4.9 billion?
4.9
Can you say more about
market worldwide?
Yeah, but I think the two numbers are not comparable.
Exactly.
4.9 is the equipment business.
No. Equipment and services. Just
I think that makes
How many
sense.
bids each day?
But
Right, you know what, yeah, I want to see that.
vendor business is about 90%. Vendor business is about
If you ask how many wireless bits were carried by 802.11 versus how many bits each year were carried by cellular, maybe the numbers are reversed. No, I'm serious.
No, you have to look to the future, right?
And also,
If all of the 3.5 billion people start doing HSP on an iPhone, the number of bits will be.
You know, you said earlier, oh, if the sort of the bits become expensive, right? People will start carpooling. If gas is expensive, they carpool it. And my feeling is that the keyboard was, well, when gas becomes really expensive, I'll ride my bike more. And I think the Skype phone is kind of like riding your bike.
No, but there's a recent study that was published that said that during the recessionary times, people actually don't skimp on broadband expenses.
Oh yeah. Okay, so now you're revealing a dirty secret, right? Which is it's a different thing, right? If, Comcast, if they have an outage, will offer you a refund. So you're like, well, I pay $100 a month for Comcast, whatever. And if you're out for all day, will give you $3 back, right? And you're like, which would you rather have, your service for the day or the $3? And you're like, no, give me the service. You pay $20 or $30 for the service. So anyway, I think the thing is that, I'm not sure I agree with this paradox because of
This is fact of life, right?
So, but that I think, as Ray says, is just, look, that is a community where just because they had access to some platform, they want to do something. Then right, so person has to contact.
Everybody wants WiMAX.
But I don't think it has anything to do with
Everybody wants to do experiments with that. So I think there is some of that these platforms were never made available for academic research. But in fact, for most of the IEEE style research, I would say it's about Spectrum, OFD, MA, MIMO, cooperative communication, none of which is.
DSA, right? I think we do a lot of DSA, and if you look at .11,
So that's
there's not much to do in DSA.
You guys are not representative.
Okay.
I'm saying if Ray stands there pointing to the podium saying we need to do more cellular research, maybe there's a sliver of hope that a professor will listen, right? But if somebody from industry comes and scream, they say,
The guy comes with a check, they'll listen, but the fact is
No, I think the more important message is stand up there and say, stop doing stupid stuff.
No, but in fact,
Yeah, but that's 98.
Yeah, I don't want to say that. But
No, but in fact, a lot of this has to do with funding sources. So if you look at academic funding, much of it comes from NSF these days. But if DARPA industry were more engaged and say you need to work on cognitive in this way or cellular in that way, cellular is harder to work on because these guys don't even discuss the technical problems that much of history. So that makes it
No, but I think my hope is that if there's an industry interaction, maybe there's a way to.
So when you're
analyze-
doing your cognitive radio experiments, that was a new radio thing.
No, so
No,
that's what
that
I
was
already
all-
said.
What is that?
It's the same, like,
The same as
we're using the same letter.
Yeah.
But it's not using FPGA, so it's still.
But
Yeah,
it's not
that-
using a
That's
cellular
true,
box.
that's.
Yeah.
No, my point is it's not a cellular box. He's not busy using some kind of experimental
Device
device provided by, that Lucent builds, right?
True, because right now I can buy this on my own.
Well, okay, so
See, I mean,
Just,
I
but
mean, if you don't have access to
98%.
experimental devices for
I
Lucent,
think
what about
let the cat out of the box just a bit. Okay. We are interested in sharing some of these concepts with the first year provider in coming months. Okay, we are going to do a lab demonstration to them of the concepts that we have working already. Right. Lo and behold, the customer shows interest. We have been told that we'll put in next degree of resources behind it. The current problem is sort of catch-22, right? They are not going to give me $500,000 to build a super duper system unless there's a customer. Unfortunately, the AT&T days are gone where there was endless supply of money. Only when the customer says interest, there's allocation of bigger amount of resources, right? So I agree 100% that the first cut prototype demonstration we are using same thing as what Elon is using, right? But the problem I'm addressing are different, right? And
But we are, as a matter of fact, I don't think we are told that much how to.
so I'm not even saying that, because academicians, they should use some big systems, right? I'm talking about the problem selection. I'm not talking about tools per se.
I agree, actually. I think mainstream cellular work was very big in WINLAB also in the 90s.
Days, I think.
But we had to migrate to many other topics, partly because that's where the funding is. But if Lucent or Ericsson comes to us with cellular problem, we listen and we often work with them. So right now Ericsson is working with us on something. So
I mean, if you look at LTE, right, there's a variety of problems there that are sort of very interesting
I don't know, I think maybe I'm not, maybe I incorrectly said it. I'm not comparing WINLAB. It's a fabulous place.
No, I'm just saying, as I said,
I'm talking about the broader community.
Yeah, but I think that's
we're
sort of
following,
explained.
I mean, we're doing what the community is doing. It's not, you can't look at us to it. So there was for a few years, right, there was a big push in unlicensed.
yeah,
There's no denial. Now, why do we focus on May 2011 like technologies? It's not because, it's only because it's cheap. I think that's pretty much the reason. I would love to see LP like technology now licensed also. Or white space, I mean, you call it anyway. To me, those are more or less.
Okay, so is there going to be, WiMAX and LTE are essentially the same thing,
Yes.
right? So we're going to see open WiMAX platforms.
That's what I would like to see.
So I see as an example, Orbit would be a classic case for doing self-fix, right?
Sure. And we do a lot of kind of research. We can help out.
Because you all of a sudden will have 256 nodes trying to do a small cluster of self-fix algorithms.
Sure.
It's a classic thing to try out, right?
And there, I think about half of the people in this room are working on some form of self-fix, I mean, whether it's sensing, detecting, or doing something about it.
So I think the optimistic thing, if I understood right, is that you're saying Verizon and folks like Verizon are interested in some of these using white spaces.
Yes, sir. White spaces, self-fix definitely in the immediate future. By 2012, some rudimentary self-fix will definitely show up in product proof pointers.
To be honest with you, I think that's fairly important. I mean, this is probably the only real case for a cognitive outside of height. Where you sort of say, okay, I can actually show you somebody how useful it is.
And I think maybe if I should correct it a little bit. We are trying to convince Verizon
I know,
in their best
I
interest.
thought as much.
So they don't
I mean, we've had conversations today. I mean, we have Verizon. They follow a lot of what we do, but they sort of keep their distance, and our interaction with them is that it's interesting, but they never sort of say anything one way or the other. Then we've had interaction with people like AT&T, right, who've shown a lot of interest depending on what was happening with their company and what they were called at various times, right?
And
Which
the
is-
company is 18.
Yeah, whatever. I mean,
Yeah.
so at one point when they were singular, I mean,
yeah.
they said we want this to go away because they've already invested billions of dollars in buying Spectrum, and they would like to build systems that are optimized and engineered for the Spectrum that they already
Yeah,
own.
but iPhone wasn't introduced before.
Right, exactly. So now if you're saying that now they're feeling the crunch in terms of Spectrum shortage, then I think probably there is hope for
I think these companies have a negative reason to care, which is that as data grows, they lose more and more money.
Yeah.
And that's a kind of a quandary because that's where the growth is going to be. Margins are negative on growing ARPU.
And it's also because this Google and all these people coming in and telling that, okay, I will, they're threatening them. And
No, but I mean, the worst nightmare is that they see that people want it. You know, that's the nightmare. That's something you cannot ignore, right? If people say, I won't use iPhone in this mode.
See, I think
right
what
now,"
needs to happen, right, like,
Then-
just like if you look at sort of power system research in this country, right, or proactivity, once they had those blackouts,
Mhm.
suddenly sort of everybody said, okay, now we have a serious problem. So, everything was
The
black.
same will happen.
So you need to have something like that happen to the
No,
cellular,
but you already have it.
sort of the cellular infrastructure.
Were you thinking about
collapsed.
blackouts many years ago, or like 4 or 5?
Just the one that happened in New York City, where people had to walk home, that sort of stuff.
See, I think that one of the issues
And
that
4 or 5 years ago, 4.
Those are
one of the issue that happens is that a lot of the thought processes are unfortunately guided by the past statistical behavior, right? That never takes into account disruptive behavioral changes, right? As an example, iPhone is introduced like every few minutes somebody pulls out an iPhone, does stuff on it, right? That is a behavioral change. Twitter is a behavioral change. Facebook is a behavioral change, right? Those can never be captured by statistical models of previous activities, right? And unless you make that leap of faith that things are changing in a different direction, they will never appreciate what you're saying, right? And unfortunately, that's where the obstacle is, that when you try to talk to some first-year provider, they say, no, I have in a Spectrum, because they haven't connected the dots, if I recall it. Right?
No, I mean, if you talk to the guys at Verizon and AT&T also bought Spectrum from the 700 megahertz, right? I mean, both of them won. Both of them have licenses. And what Verizon is doing, at least from talking to the person we talked to at Verizon, they're sort of using it to build their LTE systems, right? And so they said, we're just interested in doing this, all that white space, all very nice, but, you know,
Yeah, but I think
it's fine.
they have finally accepted that the architectural change needed.
That's a different story,
Femto.
too. Absolutely.
How to implement Femto, both solutions are equally bad for them right now, so they're still looking for something.
But what I'm arguing that if they ignore it, there will be somebody who will come up with a multimodal device that will do the same thing, and then they're in big trouble.
Yeah.
Somebody who's going to say, I mean, whether they use white space or unlicensed or whatever, will just go around their spectrum, and then they're in big trouble. Maybe Google or Nokia or somebody who is not really a provider.
I agree. Okay, great, I think I should pause. So, thank you.
Thank you.